Hello, sixth graders. We are learning about greatest common factor today, or GCF. And our learning target you need to have written down, I can find the greatest common factor of two or more numbers. Okay, so just a little recap up here. The word factor, these are the numbers that are multiplying together to make another number. So an example, 2 and 3 are factors of 6. Those are numbers that are multiplying together to make 6. Multiple we won't really touch on yet. That'll be more when we get to our least common multiple lesson. But here, this Venn diagram here. So I would write down what's here and then also write down this picture of the Venn diagram. So what they did, the prime factors of 12, they took the prime factors of 12 and the prime factors of 18 and they kind of found where it's overlapping. So as shown to the left, Venn diagrams are overlapping circles to show how common elements among sets of numbers or objects are related. They can also show common factors. The greatest of the common factors of two or more numbers is the greatest common factor. So I think that's the really important part there. The greatest of the common factors, again, factors being multiplied together, of two or more numbers is the greatest common factor, or the GCF. Okay, so have that box written down and the picture of the Venn diagram. Okay, so when we are finding the greatest common factor, or the GCF, of two numbers, in this case 16 and 20, there's three different methods that we can use. The first method is to just list out the factors. Those, again, are the numbers that are multiplying together to make 16 and the numbers that are multiplying to make 20. So we could list them all out, least to greatest, find the ones that they have in common, 1, 2, and 4. And since we're looking for the greatest common factor, that means we are looking for the biggest number that they have in common, which in this case would be 4. So that's the first method. The other method is to use our prime factorization like we learned about in our last lesson. So we make our factor trees, make a factor tree for 16 and a factor tree for 20, write out the prime factors in expanded form, and then we find the pairs, the numbers that they both have in common. So in this case, 2 and 2, and then we multiply those together. 2 times 2 is 4. So our greatest common factor would be 4. Otherwise, the cake method, or this was our kind of like our dividing by prime numbers. So we find a prime number that both 16 and 20 can be divided by, which was 2. Divide them both, 10 and 8. Find a number that both 10 and 8 can be divided by, which is 2. So we're left with 4 and 5. They don't have anything in common except for 1. So the numbers on the left here, 2 and 2, when we multiply that together, that would be our greatest common factor. So 3 methods. I'll go through into more detail on the next slide. Okay, so we are going to try this together here with 18 and 48 using each of the 3 methods. So the first method is to list out the factors. So we're going to list the numbers that multiply together to make 18. Well, 1 and 18, kind of put these in order. 2 and 9, and 3 and 6. It helps if they're in order from least to greatest. And then for 48, well, 1 and 48. I'm not going to be able to fit all of these, so I'm just going to put them 2 and 24, 3 and 16. Multiplication charts are helpful if you get stuck. 4 and 12. 5, no. 6, no. 6 and 8. 7, no. 9, no. 10, 11, and then we're back to the 12. Okay, so now they're not in order though. So numbers that they have in common here now. They both have 1. They both have 2. They both have 3. They both have 6. So the greatest of those, it's a lot easier if these are in order, least to greatest, and nicely lined up. But the greatest common factor, the biggest number that goes into both 18 and 48, it looks like is 6. So that's the first method. Second method is to use the prime factorization, so factor trees. So 18, 2 and 9, 2 being prime, 9 splits between 3 and 3, 3 being prime. So that would be 2 times 3 times 3. We're going to write it in expanded form. For 48, 2 and 24, 2 and 12, 3 and 4, 2 and 2. Again, writing this in expanded form. We've got 1, 2, 3, 4 twos. 1, 2, 3, 4, and a 3. So now we look for pairs between the two of them. So they share a 2 here, and they have a 3. They don't have to perfectly line up. They just need to show up in both of them. So then we multiply that together. 2 times 3, well, 2 times 3 equals 6. Okay, last one, cake method. This is similar to the dividing by prime numbers. So I put both numbers, 18 and 48. So I'm looking for prime numbers that go into both 18 and 48, which would be 2. 18 divided by 2 is 9, and 48 divided by 2 is 24. Both 9 and 24 can be divided by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. Now the only number that 3 and 8 have in common are 1, so we're done. So we take the numbers on the side here, and we multiply that together. So 2 times 3 equals 6. So notice every time we got a greatest common factor of 6. Any method works. You have to just pick which one makes most sense for you. Okay, so I want you to decide what method works best for you, whether that's listing the factors, the prime factorization, or the cake method. And I want you to try these 3 examples on your own. If you're not feeling confident, you can continue to watch along, but otherwise this would be a great place for you to pause and try on your own. So I'm going to do each method one time here. So for the first one, 8 and 10, I'm going to list out the factors. So the numbers that multiply together to make 8. Well, 1 and 8, and 2 and 4. For 10, 1 and 10, 2 and 5. So looking at that then, the factors that they share and have in common are 1 and 2, the biggest number being 2. So the greatest common factor for 8 and 10 are 2. Next, for 6 and 12, I'm going to do the factor trees. So for 6, we've got 2 and 3, both of those being prime. So 2 times 3. I always try to put them in order least to greatest. And then 12, 2 and 6. 6 would then be 2 and 3. 2 times 2 times 3. So now we look for numbers that show up again in both of them. They both have a 2, and they both have a 3. So I take one from each of those and I multiply them. 2 times 3. Well, 2 times 3 equals 6. So my greatest common factor is 6, which if you notice, that was one of the numbers that we used. It is possible that your greatest common factor is one of the numbers that you are looking at. So just don't be thrown off by that part. But that's the factor tree method. If they didn't, let's say you did the factor tree and they didn't have anything in common down here, then the greatest common factor would just be 1. All right, 10 and 17. This one's not the best for the cake method, but because if you look, the only number that they can both be evenly divided by would be 1. So our GCF, like I said on that last one, our greatest common factor for this one, would be 1. If you had different numbers, you would be finding what they both have in common between 10 and 17 and dividing by that number. But in this case, greatest common factor is 1. Okay, so now we have the greatest common factor of three numbers. You could still use any of the three methods for this one. So you could list out all the factors and find the biggest one they have in common. You could do the tree diagram or the cake method. I'm going to use the cake method for this one. Okay. So 12, 34, and 60. Now they're all even, so I'm going to divide by 2. 12 divided by 2 is 6. 34 divided by 2 is 17. And 60 divided by 2 is 30. Double check my 17 there. Yep, okay. Now looking at this, 6 and 30, those can both be divided by 6, but 17 can't. It has to be a number that all three of them can be divided by. Since there's nothing else, this would be our greatest common factor. I am actually going to do the tree diagram for this one as well. So for 12, 2 and 6, 2 being prime, 2 and 3, 2 times 2 times 3. 34, 2 and 17, 2 being prime and 17 being prime. And 60, 2 and 30. Going kind of quick here, just doing my factor trees like we learned about the other day. 3 and 5, 3 and 5 both being prime. So for 60, we've got 2 times 2 times 3 times 5. Now we look for what shows up between all three of them. So they all have a 2 here. The 12 and the 60 have 2s and 3s, but the 34 doesn't. The 60 has a 5, but none of the other ones do, and same with the 17. So the only number that they have in common is 2, so that means my greatest common factor would be 2. Okay, so here's the spot that I want you to pause and try this one on your own. You're finding the GCF for 30, 45, and 75 using any of the three methods that you would prefer. So pause, try, and then come back and watch. All right, so I'm going to do the factor tree for this one. Oops. Okay, so for 30, that can be split with 2 and 15, 2 being prime. 15 can be split with 3 and 5, both of those being prime. And again, we always write them out in expanded form when we're working with GCF. 45, I could do 3 and 15. I could do 9 and 5. I'm going to do 9 and 5. And then 9 splits with 3 and 3, both of those being prime. So for 45, 3 times 3 times 5. And then 75. I'm going to do 25 and 3 because I think about quarters, 25, 50, 75. 3 is prime. 25 splits with 5 and 5. Both of those being prime. So for 75, that would be 3 times 5 times 5. Again, look for the pairs, the numbers that they have in common. So I see they have a 5 here, and then they all have a 3 in common as well. And that looks like it. So I would go 3 times 5, which equals 15. So my greatest common factor for those three numbers would be 15. Okay, we have a real world example here. The Irish cheerleaders are making spirit ribbons for upcoming Spirit Week. Blue ribbon comes in 24-inch spool, green ribbon comes in 30-inch spool, and gold ribbon comes in 36-inch spool. The cheerleaders want to cut strips of equal length and use the entire spool of each ribbon. What is the length of the longest piece of ribbon that can be cut from each spool? So we're trying to figure out the greatest common factor between these three. Okay, so we have the 24 inches, and we're going to cut it into a certain length. Same thing with 36, and same thing with 30. So to do that, I'm going to use the cake method. So I'm trying to find a number that they can all be divided by. They can all be divided by 2, which would be 12, 15, and 18. 12, 15, and 18 can all be divided by 3 evenly. So 12 divided by 3 is 4, 15 divided by 3 is 5, and 18 divided by 3 is 9. Now between 9, 5, and 4, there's nothing else they have in common. So here, take that, 3 times 2 equals 6. So what that means is we are going to be cutting 6 inches from each spool of ribbon. So the blue we will cut into 6-inch pieces, the green into 6-inch, and the gold into 6-inch. So what is the length? 6 inches. Now, how many spirit ribbons can be made if the ribbons are cut into 6-inch pieces? Well, from the blue, the 24 inches, we would be able to make 4 ribbons. So I'm just taking the amount of ribbon and I'm dividing it by what we just found if they're going to cut it into 6-inch pieces. The 30 inches divided by the 6-inch pieces, we would be able to get 5 ribbons. And for the gold, the 36 inches divided by 6 would be 6 ribbons. Now the question's asking how many can they make? Well, 4 plus 5 plus 6 would be 9, 15. So they would be able to make 15 spirit ribbons. Okay. Notice I'm using my label to match what the question is asking, how many spirit ribbons. Okay, on your own, you're going to do these 3 examples at the bottom of your notes. You're going to find the greatest common factor of 12 and 78, the greatest common factor of 5 and 6, and the greatest common factor of 36, 60, and 84. So you're going to do those ones on your own. I'm going to be looking for them at the end of your notes. So that's all for greatest common factor. If you are stuck, remember you can always go back and look through your notes or rewatch parts of the video. Check to see if this is something that you could explain to a friend. If it is, that tells you you've got a pretty good understanding of it. Otherwise, you can always try more practice problems, and then don't forget to post your notes to Class Kick.